Hello. It is my pleasure today to talk about a new approach to video at scale over the internet. I'm going to be talking about the Content Fabric Protocol, which is a new decentralized and open protocol for video from source to output, built with the concepts of bringing media and metadata and processing all together in one dynamic protocol. The features of that allow for new types of interactive and live content experiences, latencies, and also simplicity. The protocol itself brings together the functions we've traditionally thought of as separated content distribution and media stacks for transcoding and packaging, as well as security into the protocol itself. It's also designed to be tamper-proof and allow for content provenance through the blockchain security model, and really sets it up to be a foundation for the new video economy. So you may be wondering, why did we do this in the first place here at Eluvio? At the top line, we all know that video is most of the internet. It's over 80% of the traffic. It's also $500 billion of value, expected to grow over $1 trillion of value. And yet, even so, the ways that we deal with video over the internet were really designed for data. And arguably, we're still approaching our content in video workflows with files and bytes rather than doing it content natively. We can see the results of that in the complexity that we face. Most modern professional media workflows are really complex, and they are multi-tier. They typically have a number of microservices that are knitted together. And then finally, there are certain constraints about the efficiency, the scalability, and also the latencies that CDNs and media clouds together have sort of forced upon the situation. The Content Fabric Protocol is content native. It's built so that we can not only address content in a way that fits its characteristics, it's also built to allow for all of the functions that we typically think of in multivariant content to actually be part of the content itself. Finally, it's designed to be self-proving, which is very important, we think, in the way that the economics are shaping up. We all know that very little has changed about how we package and deliver content over the last 23 years now. In fact, I think the same workflow has been going since about year 2000. We typically start with source media. We then transcode and package it into several file variants. We usually push those then to origin servers. And finally, we rely on a plethora of CDNs to provide edge caching to improve the performance to the consumer. Of course, this has many challenges, as we all know, the top of which, of course, is internet congestion, the limitations in having to do this over and over again with so many file variants. And then finally, the constraints that multi-tier final to edge architecture forces upon what we can do. And we see this especially when we think about the fact that most content has many different variants of the same thing that are not only published by one company, might be published by many. Think about an international feature film. There might be over 200 different variants by the time you think of the subs and the dubs and the DRM and the packages that we produce along with all the bit rates to the consumer. Also, with cloud-based services, which have obviously become the norm over the last 15 years or so, media, metadata, and processing are not together. And we have to go through many contortions to try to bring them together in our complicated workflows. And then the content economics are really in favor of the distribution platform, not in favor of the content owner or the creator or even the audience. Finally, when we look at an application like content or ad insertion, we can see this all coming together. We have an inherent trade-off between the server side and the client-side implementations. On the server side, it's almost impossible to personalize. It can also be slow and also difficult to get a good experience. If we work on the client side, we might be able to personalize, but we can't scale. And along with that, we can see that most of the stitching architecture really is a profound example of the fact that the media, such as the base live channel, the metadata that's going into deciding how to stitch, and the actual stitching itself are all separated. If we look at this in the pipeline, we see something like this. We've got our core content coming in, being transcoded and packaged. We have some kind of server-side ad stitcher technology that might even be elsewhere. And then we have the control and the data that's trying to drive this from the ad content standpoint. So this brings me now to the foundations of the content fabric technology, which is really quite different from the approaches of the past. Most importantly, this is built as an internet protocol. It's open. It's open so the protocol nodes can be extended at any time, and all of the nodes run the exact same software, much as we think of BGP routing in the internet. It's application layer and built to be fast. Fast so that we're not doing file I/O stop-offs, and so we can have fully pipelined serving from the raw source parts to the output that the consumer is experiencing with 4K live streaming as well as interactive content. It's simple because all the functions are built to tie together in the protocol itself by design as opposed to being workflow-based. And it's built to be efficient. Efficient so that composable content, multivariant content is built intrinsically rather than being done through the upstream of the workflow. It's secure. The content itself protects itself in a trustless model that combines together the encryption and the DRM and the authorization. That also leans on the state of the art in blockchain security, and it's transparent. The transparency allows for engagement to be proven on chain and also the access control in the content to be inherently part of its versioning. And finally, it's just in time and able to self-compose. This allows us to do personalized, stitched, and interactive kinds of experiences that we couldn't do before and makes the lift on that easy for those that develop it. So with that, I'd like to take you into the details of the protocol. We've examined that it's one software stack. It's content addressable. And this is very unique because content objects underpin the way that content is stored and referenced in the network. I'll be showing those in just a minute. All of those content objects allow for self-composition and creating just-in-time output. Blockchain security, authorization, and also version proofs are foundational to how it works, and every operation in the protocol is fully pipelined. At the very top, the content object is the way that all content is referenced and stored. It is a copy on write structure, which means that as new versions of content are created or objects are created, all of the previous version is maintained and only those parts that need to be updated are added or changed. Also, the content object has a cryptographic hash, which becomes its signature. That hash is committed in the blockchain of the protocol, which is the other facet of it, and allows for storing that version as it evolves over time. This object mechanism combines together with the dynamic aspects of the protocol so that when a client comes to the fabric and makes a request for a URL, that URL is literally evaluated on the fly. That process will refer to the lowest layer of the protocol that knows how to locate the base parts of that content object, which can be raw media, metadata, or code, to then bring those over the network to render the code against the media and the metadata and produce the output. And finally, that process is under the control of an interface for access control, also governs the encryption of the parts from the source party to the receiving party, including with strong DRM, through the blockchain contract that's associated with that content object. What's really, I think, remarkable is the fact that every content operation, whether we're producing HLS or Dash streaming video, file downloads, TARs, images, static metadata content for just reading on web pages, you name it, all follows that same process. And all of the source material that comes into the fabric is one of these base content objects with the parts that are built and sharded throughout the nodes in the network. This is governed, of course, by blockchain authorization that is inherent in the content objects. This is really interesting because it means that when this kind of componentized and dynamic output is being accessed, that access goes against a policy that's data in the content object itself and also committed on chain as part of the object's version. That policy can include any business rules. So you can do things like windows on theatrical content for time or geography. You can enforce traditional user and group access control. You can also implement content monetization, where this becomes a way of providing access passes or enforcement of subscriptions. And finally, you can take it all the way to a pure Web3 native approach where the criteria for getting access is whether the accessing client owns an on-chain blockchain instrument like an NFT. Finally, this all combines together into a global and open network. As I mentioned, the nodes that run the Fabric protocol, because that protocol standard, nodes can be added at any time, and they all run the same software stack. So any node can provide ingest, any node can provide egress, and all participate in the storage and the serving of the content object parts as part of the dynamic just-in-time rendering protocol. What are the results? Well, you can use this for live streaming, for VOD, you can use it for server-side ad insertion, you can use it for automatic search and clip generation, you can use it for interactive content, and you can also use it for building factories of media tied to on-chain ownership. Now I want to show a few demos of this, and I want to just start with an animation that will let you see how this works in practice for publishing VOD content. So in this case, you can see we have a file-based media source. The ingest process within the Fabric creates parts that then are assigned to nodes in the network according to the decentralized hashing and partitioning algorithm. Those parts are then fetched on demand as a client makes a request to any node. Those parts go over the network and are processed just in time through a just-in-time transcoding capability that's part of the core Fabric protocol. And then finally, you can see that the technical metadata that's part of the base content object is also accessed as needed to determine things like, for example, what bit rates are being used when that just-in-time happens, just-in-time transcoding happens, what audio tracks are included, etc. Finally, it's important to sort of appreciate the pipeline that's happening here. You can see there are no stop-offs. So instead of making a file version, transcoding, pushing all those variants across, waiting for those file transfers to happen, hoping that you've got stuff cached at the edge, instead that dynamic pipeline supports each client's request wherever it happens in the world and without those stop-offs. And we can take this another step and apply something like forensic watermarking. Notice that nothing changes. The only difference is that now, instead of making a single version of the parts, if we're using, for example, something like the Niagara watermarking technology, there are two versions of the base media parts that are generated. And those two versions become base parts that are requested. And then the just-in-time process can actually utilize things like or be extended with the watermarking algorithm to determine the composition of a sequence, that sequence then being used to generate a unique A-B segment pattern. What's important about this is that any kind of compositional function, not just forensic watermarking, but anything you might want to do in the pipeline can be applied this way and extended without having to build a custom workflow. And I wanted to just do a quick demo here. So we'll play out Warner Brothers Flash, which is utilizing this technology. And a couple of things that are really, I think, fantastic are the Flash here as the feature film is being served directly from the Fabric, a single master object, including support for all of the different language dubs, of which there are, roughly 20, 30 provided by Warner Brothers. The transcoding is done just in time. The windowing for access control, because this is a digital OTT film release, is enforced directly in a policy on the content object itself. So we do not have a traditional CDN, we do not have a media cloud, and we do not have external functions driving rights or DRM. All of that is provided for in this one dynamic pipeline with one source object in the content fabric, playout happening globally. And of course, this is interesting because it allows us to also get at per user engagement, session by session, and opens up transparency in terms of knowing what's happening in our pipelines. The live streaming case is similar to VOD, the only difference being that the fabric advertises the core parts ahead of time so that that full pipeline stays consistent and full end to end. And this allows the HLS segments being generated to the player to be delayed literally just the 2-second segment duration plus a few hundred milliseconds of propagation time. End-to-end live streaming latencies of 2 to 3 seconds globally for any client without having to perform contortions in the network or in the protocol. And I'd like to do a quick demo of this as well. I'm just going to pop over here, and you can see this is a live stream of FS1, one of the feeds coming into the fabric being streamed out with HLS. And this is actually using the ultra low latency player profile we've configured on our HLS.js open source player. The end-to-end streaming latencies here are 2 to 3 seconds globally. And notice we're doing this without any custom protocol configurations and with just the responsiveness of the fabric pipeline. Now, finally, we can take a look at this in the context of ad insertion and dynamic content insertion. Same idea applies, but we extend our pipeline now so that we are not just doing live streaming, we are also inserting in that just-in-time pipeline additional content. In this case, ad content. And you can see we can also capitalize on the capability of the content objects to have custom code in their WebAssembly stack that's part of the protocol. That custom code can then read data and also execute so that it provides the insertion functions. Those insertion functions can be any business policy. And then finally, it's also interesting to note that metadata can be added dynamically to the live running streams to trigger those insertions. So you can do it directly from an API or from traditional triggers like SCSI sources. We now have a self-serve architecture for content insertion, ad insertion, which can apply any business logic and bind together the content with the user data without limitation. And finally, I want to provide a quick demo of this, which I'm going to do on the Apple TV. This is a live streaming channel, weather channel coming to the fabric and streaming out on an Apple TV that I've connected directly to this demo. I'm going to trigger an ad insertion through the API. This will be using a selector function, which is actually code in the fabric that will then choose the ad, which is also in the fabric to bind into the channel. It's going to do that based on a simple algorithm in this case that selects a local ad for the region of this content. I just triggered it, and that will come up in roughly 10 seconds. One of the things you can note about this is it's entirely data-driven. So we can make that function, the selector function, as advanced or simple as we like, and with whatever business policies we like. And here you can see we have the Arizona Lottery ad. This will play out, and then we'll be switching back to the main Weather Channel feed. No external software, no custom workflows, just fabric functions. Kevin likes the lottery. And we're back. Hopefully you've enjoyed these demos showing you what you might do with the Content Fabric protocol for your live streaming and your VOD streaming at scale. We look forward to hearing from you. Feel free to connect with us via our website, Twitter or LinkedIn, or contact me directly, michelle.munson@eluvio.io. Thank you.